So Cramer's method is a way to kind of write down a mathematical expression for one of the answers out of your simultaneous system. So in order to use it, I need to first convert this system of equations into a matrix. So I do that just by reading off the coefficients, which I will just do right now. And so once I have my my system written as a matrix, I will do it as a full matrix equation just for clarity. So I have in particular this system here. So these coefficients multiplied by this vector of unknowns is equal to this vector of constants. Now I could assign some names to this, so I could have a times vector x equals vector b. And then I can use Cramer's rule with this notation, or Cramer's method with this notation. So Cramer's method says the following. So Cramer's method says that my unknown, which I'm going to call V here because these are voltages, so Vk, is equal to a thing called Nk divided by a thing called delta. So how do I evaluate those? Where delta is the determinant of this A matrix. I'll explain in a minute how to calculate a determinant if you have not heard of that before. Where delta is the determinant of A, and Nk is the determinant of a matrix where the kth column is replaced by b, our vector b. So that's perhaps a little complicated. Let's do an example and I'll explain to you how this works. So the first thing that we need to learn is how to calculate a determinant if you are unfamiliar with that. So in particular here I have that my parameter delta is the determinant of my matrix A, and so we often write determinant just with like a vertical bar around this matrix. So here is the notation for this determinant, and the rule for determinant works like this. So I take the upper left cell and I write 4 times the determinant of the matrix in the kind of other columns and the other rows. So the matrix in the other columns and the other rows, so that's the determinant of 5, 14, minus 15, and 15. Then I have a minus. I alternate signs, so I will have now minus, and I'll go through and do a similar procedure for the next column here. So I have minus of minus 3 times the determinant of what I get with a matrix that has the other columns and the other rows. So the other columns here are minus 4, 14, minus 2, and 15. And then positive, I alternate signs when I'm using this method to find the determinant. Oops, let's not erase too much there. Just trying to get rid of my highlight. And I'll put that line back. And so this will be plus, well, it's 0 times the determinant of, I'll just explain what I would do if it wasn't 0. So it would be the determinant of minus 4, 5, minus 2, and minus 15. But I don't need to bother with that because it's just times 0. So now how do I evaluate the determinant of these 2 by 2 matrices? Well, there's like a diagonal product rule here. So I take the product kind of down this diagonal. So this is 4 times 5 times 15. And then I do a minus of the product down the other diagonal. So the product on the other diagonal is 14 multiplied by minus 15. That's the first term. Then I will have, that's a plus 3, the 2 negatives will cancel, and then I do my diagonal product. So that's minus 4 times 15, minus 4 times 15, minus 14 times minus 2. And then the last term is 0. So this now is just a big, long formula. So we basically type this into our calculator. So I'll kind of do this in a few steps. So 5 times 15 minus 14 times minus 15 is 285. This will be plus 3 times, and I will calculate here, this is minus 4 times 15. And the two negatives will cancel, so it will be plus 28. So that is minus 32 that I will get there. So I can then multiply and add these out. So that's 4 times 285 plus 3 times minus 32 is 1044. So my delta parameter for Cramer's rule is 1044. That's the determinant of my A matrix. Now suppose that I wanted to solve for just V2 in particular here. So if I want to solve for just V2, then I need to form a new matrix which has the second column replaced with my B vector. So I'll draw it over to the side here so that you can kind of see what I'm doing. So I'm going to keep the first column, and I'm going to keep the last column from my A matrix, but my second column I'm going to replace with my B vector. So this here now is the matrix that I need to calculate the determinant of. So I'll just grab that and kind of move it down here so that I can have some space to work with. So what I need here for my Cramer's rule is to find the determinant of this. So my nk, which is 2 in this case because I'm solving for the second unknown. So n2 is the determinant of this matrix. So I'll just put the little bars there to indicate that I'm calculating the determinant. So now we use our little method. So that's 4 times the determinant of the matrix in kind of the other diagonal corner, minus 36 times this matrix that I get with the other columns. So that's a minus 4 and a 14 and a minus 2 and a 15. And then finally a plus 0 times the determinant of this other matrix. I'll just write it out so you can see the pattern. So it's just the other columns in that matrix, and I form the determinant 2 by 2s there. Let's multiply or write down what these are. So this is 4 times the diagonal product, so that's 120 times 15 minus 14 times 0, minus 36, and this one will be minus 4 times 15, minus 4 times 15, minus 14 times minus 2, plus 0. Let's calculate this. So the term inside the brackets there is 120 times 15. So this is 4 times 1800 minus 36 times, in the brackets there is minus 4 times 15. Plus 28, so that is minus 32, and the 0 does not contribute. So then 4 times 1800 minus 36 times minus 32. So this is 8,352. So now I can use my my Cramer's method, which says that my second unknown V2 is n2 divided by delta. So that was 8352 divided by 1044. which is 8352 divide 1044 is 8. So I get 8 volts. So by using this method, I can kind of go straight to one of the answers in my simultaneous system. So just to recap the application of Cramer's method, basically the fundamental equation is this one here that says that we calculate the kth unknown by this ratio nk divide delta. So delta is the determinant of the A matrix. The A matrix is this set of coefficients for each of the variables. So the determinant of the A matrix gives me this delta here. And then nk is the determinant of this new matrix that I form, where I replace the kth column of A replaced by B. So I take the kth column of A and replace it with B. And that gives me a new matrix. I take the determinant of that, so it's basically two different determinants, and then I get the actual solution. So this is kind of magical, right? This procedure of taking determinants, this is really not obvious that this actually works in getting you the solution to a simultaneous system of equations. But it's kind of a guaranteed method, right? This is just like a formula you can write down, and you just get out your calculator and start calculating, and you'll get yourself to the answer. Kind of a fully mechanical procedure that you can follow.